We're on to lesson 6 on trigonometry. The first lesson, trigonometric ratios for any angle in standard position. For this specific section, we'll be using the unit circle to determine the trigonometric ratios for angles less than 0 and greater than 360 degrees. The goal for this lesson is determining and sketching coterminal angles. Also, we'll be sketching standard angles in standard position with the same terminal arms. And when I say coterminal angles, angles what they call in standard position. A standard position angle is an angle where the vertex is located at the origin and its initial arm lies on the x-axis. So we will be looking at this in detail. Here we have the initial arm. So we call this arm. And this would be the terminal arm here. So this is an overview of today's lesson. So I'd like to do a little bit of review before we go into the concept of coterminal arms, standard position. Okay, let's get started here. We'll have to do a little bit of review from grade 11. If you recall from grade 11, the Pythagorean theorem, which states that if you have a right angle triangle, then the square of the adjacent side plus the square of the opposite side is equal to the square of the hypotenuse. So if you recall what we have a right angle triangle. And here is our reference angle. This would be the opposite side. This would be the adjacent side. And this is your hypotenuse. And this we refer labeled as C. This would be B, and this is labeled A. We see that C squared is equal to A squared plus B squared. That's a standard, the Pythagorean theorem. So we'll use that concept to find here the exact position of this point x, y. Now this is a circle with a center at its origin and an angle of 45 degrees with a radius of 1. And this is normally we call it a unit circle because the definition of a circle, which we'll find later, is x squared plus y squared is equal to the radius squared. But if we make the radius 1, it is x squared plus y squared equals 1. So this is what we call a unit circle. We'll go into details later in our next lesson. But for this lesson, here is a circle. The origin is 0, 0, 0, and the radius here is 1. What is this point here? First of all, let's construct a perpendicular line, right, from P to X. So that's 90 degrees there. So I'm going to make this a broken line. So we have this here. And you can call this whatever letter you want to call it. I'm going to call it, let's call it N. Could be any letter. Now, this is an isosceles triangle because this angle here is 45 This also should be 45. And this is 90 because the base here, right? Because it's perpendicular. So since this angle is 45 degrees here, triangle PON is 45 degrees. So we can say that here, right? So here we did a perpendicular. So triangle PON is isosceles. Because it's 45 degrees, right? So we can say since angle PON is 45 degrees, then triangle PON is an isosceles. So therefore, PN is equal to ON. So we can say PN is equal to ON. Right. Now, if we're going to use, this is the Pythagorean theorem, and this is P, this can now a little bit changes around. I'm going to transfer this as N, and this is O. So we say ON squared plus NP squared is equal to 1. In this case, it is 1, or C squared. So we can conclude using Pythagorean theorem which is A squared plus B squared is equal to C squared. So now since C is 1 squared, A squared, let's call this A and this B. Let's say that's ON squared plus NP squared is equal to 1 squared. Now, since ON is equal to PN, we can say that we can make them all ON. So we can set 2 ON. So we have ON, make this plus ON squared is equal to 1. Now, we have 2 ON squares here. Now solve for ON. Right, so we can solve for ON. So we'll have divide both sides by 2. So 2 goes into itself 2 once. So we have ON squared will be equal to 1/2. Now we want to get rid of this square here. So we square root both sides. So we have ON squared square root is equal to the square root of 1/2. So now we end up with ON is equal to 1/√2. Now, since ON is equal to PN, so is also PN. PN is equal to 1/√2. So that's, we have the point. So this point here now, ON squared, it will be X here, will be 1/√2, and Y would be 1/√2. So we can conclude coordinates of Pxy is equal to 1/√2, 1/√2. So we can conclude, right, that if we really look at the Pythagorean theorem, we can conclude that the point P and X are the same value. It's for on the unit circle. By the way, let's review a little bit of what we you must have done in grade 11 regarding the trig ratios. we call it when you have a triangle, your reference angle, and here we have the opposite side, we have the hypotenuse with the adjacent side, because we're using this as our angle. We have the trig ratios. Remember, the trig ratios are sine theta is the opposite over the hypotenuse. Now, if you were to make this x, and this is going to be, in this case, sorry, just be y, and it's going to be x. It will be y over, and we call this will be the radius r. Sometimes you'll see it written, sine is, in this case, opposite over, in this case, be y over r. Cosine theta is your adjacent over hypotenuse. And we can write as x over r. Tangent now is y over x. So tangent is equal to your opposite over your adjacent, which is y over x. So recall these are three trig ratios we'll be using. And this will lead us later on to what I call the reference triangles, which we'll be doing in the next lesson. But for now, I want you to recall your three trig ratios, your Pythagorean theorem. We'll be referring to these in a moment. So this is what we'll be using here. Now, let's go on to the next part of the question. The next part of the question says here, okay, using the same, what we found here, we discovered the form PP here is 1 over root 2, 1 over root 2. The angle between 0 and 360. So determine the value of pi of alpha that satisfies each equation. So sine alpha is 45 degrees. Look at that first. Okay, so let's look at sine alpha. What it means. Now, I forgot to just mention to you in a minute here, if we were to look at this graph here to find tangent of 45 degrees, now this is 45 degrees. The tangent, which is opposite over adjacent, it will be root 3 over 1 over root 2 over 1 over root 2, which is 1, or y over x. So there's going to be y here. Bx. So tan 45 degrees is y over x, which is 1 over root 2 over 1 over root 2, which is equal to 1. And if you would try that in your calculator, assuming you're in the, see my mode, let's work in the degree mode. So tan of 45 degrees is equal to 1. Okay, so let's look at the other reference angles you would like us to find. 45 degrees. So we're looking at angles between 0 and 360, which is a complete circle. So since, now here what you have to remember, when we call from grade 11, they call it CAST rule, C-A-S-T. It means a cosine is positive here. All of the trig ratios, like cosine is positive, sine is positive, and tangent is also positive here. Here, only the sine is positive. The rest are negative. Tangent is positive here. So cosine and tangents are negative here. And sine and cosine are negative in the fourth quadrant. So quadrant 4 here. It's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So cosine is positive in quadrant 4 and 1. Sine is positive in quadrant 2 and 1. And tangent is positive in quadrant 3 and 1. Okay. So now if you were to find, right, that sine now is positive here. So sine, we can see here. So sine alpha in the case which we looked at here. So sine is 45 degrees. Looking at here, I'll just back to our reference. So now we have sine theta is equal to sine 45 degrees, right? So we have, it's given here, right? So we have 45 degrees there. Now, sine is positive in quadrant 1 and quadrant 2. So the first one, sine is positive in quadrant 1, 45 degrees. So we can see sine alpha in the first case is 45 degrees. Now the next one where it's positive, it will be 45 degrees here plus 90. Or 180, it's 180 degrees here, minus 45. So we can say that again. We can say sine alpha is going to be equal to 180 degrees minus 45, which gives us 135 degrees. So from the initial arm, this would be your terminal arm, this would be 135 degrees. Cos 45 degrees, so cos is positive in quadrant 1. So we can say cos alpha is 45 degrees. And alpha, because cos is positive in quadrant 1 and quadrant 4. So it's positive in these two quadrants. So if I were to, so this is cos 5 degrees, positive here. Quadrant 1 and quadrant 4. So alpha is equal to 45 degrees. Alpha is equal to 360 degrees. Now, it's 360 minus 45. So this angle here would be 360 minus 45, which gives you 315. So 360 minus 45, which is 315 degrees. So this is 315 degrees. The last one, looking at tangent. So tan is positive, so it's given here. So tan alpha is positive now, tan would be positive in quadrant 3 and quadrant 1. So notice, right, this is 180 degrees, so it will be adding on. So 180 plus 45. So alpha is equal to 180 degrees plus 45 degrees, which comes up to 225 degrees. So if I were to do a sketch of that here, So all the way from here to there would be 225 degrees. I just want you to I want to remind you that there's something called the reference triangles, which we will be looking at later on. And that will help us to understand the whole concept regarding these angles here. Sorry, the measurement in radians. And what the reference triangles look like, just have it here right now. So we'll have a triangle. So we know all these trig ratios, which we'll be looking at next lesson. And this is something I'll give you a prelude for. If you have a reference triangle, this is 60 degrees here. This would be 1, 3, and 2. It would be 30 degrees. Then we have the 45-degree one, which we just did. And if we refer to this as root 2, this would be 1, 1. This is going to be the two reference triangles we'll be looking at in this lesson. So let's look at some terms. And standard position. We're looking at an angle is in standard position with its vertex located at the origin and its initial arms lies on the x-axis. So this would be an example. Here we have our initial arm on the x-axis. Or call it initial side. So this would be called initial arm, right? The terminal arm now is the other arm to the initial that defines the angle. So the angle in between the initial arm and the angle or the line, right, which we call the terminal side, defines the angle. Whenever we go in counterclockwise, position positive angle. In other words, we're going from here's the initial arm, going counterclockwise, positive. If you're going counterclockwise from this initial arm is x, now this is negative. So here is an example. When a ray, this is your ray, rotates, let's say in this case 130 degrees, counterclockwise, this is anti-clockwise or counterclockwise, from the origin, it formed a positive angle. So we say positive angle, 130 degrees. Now you can have more than 360 degrees. If on the other hand, you have a ray that rotates once, comes back all the way. Say, for example, let's do a sketch here. So here's our angle here. So there we go, from there. Now, let's say from here to here, it's 200 degrees. Now, if you were to make another complete rotation, so take this one here. So you start from here now and come back here. That will be a 360 degrees. Because here you have 0, starting off from 0, 200 degrees. Now, if you were to complete here now, start from here, and go all the way around now. Come back. That's 360. So that's what this is all about. So this comes here, and this other part here is 360. So it will be 200 degrees, which is one here, plus 360 degrees. It gives you 560 degrees. So after it reaches its terminal arm, it's 200 degrees. If it rotates a complete cycle, it's another 300 degrees. The sum is 560 degrees. Notice these are all positive angles, right? Positive, notice they're positive angle, but the positive is not written in front of it. So positive 360, positive 130. Now, if it goes counterclockwise, as in this example here, right? It's going counterclockwise. So this would be counterclockwise. You see the angle it forms is negative. So you see a negative in standard position. So this is an angle in standard position that's positive. So we see standard position. Because by definition, standard position and angle is in standard position with its vertex located at the origin and its initial arm lies on the x-axis. So here is the initial arm. That's your terminal arm. So the angle between the x-axis and the terminal arm is referred to an angle in standard position. So the angle in standard position is referred to as the angle in standard, as positive. So it's positive in this case here. Now, on the other hand, you have an angle in standard position is negative. So angle in standard, standard position. And this one is negative. Oh, sorry, this one is positive in this case, but it's more than standard position, but this is positive also. Now, when it's going counterclockwise now, in standard position, it's negative. So this is clockwise. Oh, sorry, this should be clockwise here, not counterclockwise. This is clockwise. This is counterclockwise. So counterclockwise, the angle in standard position is positive. Clockwise, it's negative. Here's another one here. We go once and twice. Okay. So once we go around once and come back twice. So we have, in this case, we have an angle of would be 360 plus 200 in this case here. So we go around once, clockwise here, that's 200 degrees. So 200 degrees plus 360 degrees give you a total of negative 560. Okay, now these are in standard position. Okay, so when we start from the initial arm to terminal arm, counterclockwise, the angle is positive. Counterclockwise is positive, and clockwise is negative. So clockwise, the angle is negative. Now, let's look at coterminal angles. Angles in center position with the same terminal arm. Right? So that's the definition for a coterminal. Angle in center position with the same terminal arm. Now, there's infinite amount of coterminal angles. Right? So this one didn't show up that well. So here we have X and Y. So here we're going counterclockwise. That's 130 degrees. If you were to continue this now, numerous times, let's say one more time, so there's another coterminal arm. And if you continue this, you can have infinite amount of coterminal arm. So this is 130 degrees, the beginning one. If you have 360 degrees now to this gives me what, 490 degrees. Then I add another 360 degrees to this. I have 5, 360, 7, 850 degrees, correct? Let's see, 130, oops. 130 plus 360 gives me 490. And you can see there's a formula for that. Now, if you continue going, plus 360, that's the other coterminal arm. Then you add another 360, and you can see it goes on forever. So these are referred to coterminal angles. And the formula for that is whatever the angle is, in this case 130 plus 360 k. K refers to a whole number. So if you take the first terminal coterminal arm, it will be the angle plus 360 times 1. And the second one will be the angle plus 360 times 2. The angle theta plus 360 times 3, etc. So this is where you're going in, referred to as the counterclockwise, right? So this is counterclockwise. Now, if you go into clockwise position, now you subtract. So you're starting from the bottom here and you're going down, right? It's negative already, right? So whatever angle you have there, you will then continue to subtract in this case. So let's look at this couple of examples. Here we have 400 degrees. So 400 degrees, right, is equal to, is 40 degrees here, and go around another time. So 40 degrees plus, okay, the initial angle is 40 degrees plus 360. Now, if you were to add this on here, 400 degrees plus 360, and that's the next one, which is 760. Which basically it is, looking at a formula here, it's going to be 360 degrees times 2 plus 40 degrees, which is 760. If you're looking for 1, it'd be 360 degrees plus 40, which gives me 400 degrees. So this is for positive angles. So positive angles, for positive angles, the coterminal angle, angles is where the angle is plus 360 degrees times k, and k is an integer. Now, in this case, now we're going to in a negative category, right? So a measurement for a negative angle. So these are coterminal with 40, right? Negative angles coterminal with 40 degrees. So if we use our formula is theta minus, right, 360 degrees times k. So it's 40 degrees. So 40 degrees minus 360, which gives me, what, 320 degrees negative. So that's how we get negative 320. If we continue that, 40 degrees minus 360 times 2 twice will give us, let's get a little calculator here. So 40 minus 360 times 2 would be negative 680. Now, if you were to continue this, you could have gotten another one, 40 degrees minus 360 times 3. So 40 minus 360 times 3 be negative 1040. So you can see you can continue this forever. So that's what, okay, so for this here, so coterminal angles in standard position with the same terminal arm. The coterminal angle can be found if it's you're going counterclockwise. It is theta plus 360 degrees times k. If it's clockwise or negative, so we can put here. So this is positive, and this is negative. Is theta minus 360 degrees. So the measure of any angle coterminal in standard position can be written in this form. Let's see how this works out in one example here. So determine the measure of all angles in standard position between negative 1000 degrees and 1000 degrees that are coterminal with the angle of 150 degrees in standard position. Sketch the angles. And part B, write the expression for the measure for all angles that are coterminal with an angle of 150 degrees in standard position. For this one here, you'll have to use you can use a calculator for it, but we'll stick with the basic sketching. Let's look at the first one here. So between 0 and 1000, so let's look at the first that we sketched here. We have an angle of 150. So we have an angle of 150, which is, this is 90 here. This is 90, so 150. So this is 190 here. Sorry, 180. This is 90. This is 0. This is 270 degrees. So 150 will be right over here. So this is 30 degrees here. So from here to here is 150 degrees. So using what we know from before we going in this case, we're looking at a counterclockwise, it'd be theta plus 360. So this is positive. So we're going counterclockwise, which can give me theta plus 360 degrees K. So we know the first one is 150 degrees, right? It's given. The next would be 150 degrees plus 360 degrees, which can give me, what would that be? 0, 5, 6, 11, 510 degrees. So that's still below 1,000, right? Okay. So the next one, by the way, they said they have to, this would be in standard position because the angle in the one in positive, we have to make it positive here, right? So the next one now would be 150 degrees plus 360 times 2. Now this could be 1 here. Put our calculator out here. Let's say 150 plus 360 times 2. Give me 870. Degrees. So now if we were to continue that, let's try one more. 150 degrees plus 360 times 3. So 150 plus 360 times 3. Now that's way above 1,000, so that will not work. Because the question asks you between negative 1,000 and 1,000. Okay, in standard position. So here we have now between 0 and 1,000 degrees. Now let's find between negative 1,000 degrees and 0 degrees. Okay, so now let's look at the other set. So if we were to continue this sketch here, so we have this here, this will continue. And this would be the 510. This would be 510. If you continue this, this one here will be 870 degrees. Let's do a sketch here now. Let's over here. Continue our sketching. Still have 150 degrees here. This is 30 degrees here. So we have, that would be 150 degrees, but that's in the positive direction. So we want in a negative direction, right? So we have to go clockwise. So remember this is counterclockwise, go from here to here. It's my x-axis. So this angle here is 180 plus 30 gives me 210. No, yes, 210 degrees. Will be negative 210. So negative 210 degrees. Because we're starting from 0 here. So 180 plus 30. The previous one we're starting from 0. Going counterclockwise, that is 150 degrees. So let's look at the pattern. So we have 150 degrees. Now we're going to use a theta minus 360 degrees times k. So this is, we have the first one would be 150 degrees, right? Minus 360 degrees gives me negative 210. That's what I got there. Next one will be 150 degrees minus 360 degrees times 2. Should put that negative there. And that would be 150 minus 360 times 2 be negative 570. The next is 150 degrees minus 360 degrees times 3. Gives me negative 130 degrees. And you can see the next one, if you were to try it, let's see, what would it be? Minus 360 times 4. That goes way above. So this one is above our 1000, same as the one we had earlier. So this is what you do to find all of the coterminal angles between negative 1000 degrees and 1000 degrees. So we'll use, so the measure of all angles that are coterminal 150 can be expressed by this theta plus 360 times k, where k is an integer or a whole number, a positive whole number, or in this case. So your assignment question would be to look at check your understanding. So you will want to look at check your understanding question, which is this question here, determine the measure. Try that between 800 and negative 800. All right, instead of write an expression. Oh. So try that. Now the last part here is to write an expression in the measure of all angles that are coterminal. So that would be for B. So B, it would be 150 degrees plus 360. Here we go. So 150 degrees plus 360 degrees times k, which k is a set of integers. Okay, let's review what we did today. So our goal today was to determine and sketch coterminal angles. We say coterminal angles are angles in centered position with the same terminal arm. Centered position is an angle in centered position with its vertex located at the origin and its initial arm lies on the x-axis. So this would be an example of an angle in centered position. The terminal arm refers to the arm that defines the angle. The initial arm is where you start from. So angles in centered position with the same terminal arm referred to as coterminal angles. And we conclude that given an angle, all of its coterminal angles can be defined in terms of theta plus 360 degrees times k. And we concluded with one example to find all of the coterminal angles.